Quick Maths Made Easy YouTube channel, Functions and Graphs, and Introduction. We're dealing with the hyperbola and the video number 100. We know the hyperbola is represented by y equals to a all over x minus p plus q. And we know that when a over x is positive, and then your graph will be on the first and the third quadrant. Like here, when f of x, so a is 4 and over x, and p is 0 and q is 0. So your p and your q are your asymptotes. So you've got your vertical asymptotes when p equal to 0, which is same as when x equal to 0. And then you've got your horizontal asymptotes when y equals to q, and y equal to 0. So when f of x is equal to 4 over x, where p and q are 0, your graph is in the first and the third quadrant. And then similarly, the other one, when the h of x equals to negative 2 over x, your graph was on the second and then on the fourth quadrant. But now we're not there. I just want to demonstrate or to illustrate the axis of symmetry. Axis of symmetry, remember in the parabola that on the parabola your axis of symmetry, is the line which divides the graph into two, so the graph can fold. So here too, our axis of symmetry, if you look at this negative sort of gradient, so you can see that this graph can fold. So you can take this one in the first quadrant and just lay it on top of the one in the third quadrant. Or similar, you can do the same thing from the third quadrant and then you can lay it on top of the one in the first quadrant. But you also got the positive, the gradient. Positive gradient is also the axis of symmetry. So here, this line here can just fold and lie on this line. Or that line can lie on the other line. Similarly on this third quadrant too. So this line, if you fold it here along the axis of symmetry, will just lie there. So it's easy to explain the axis of symmetry also in the hyperbola, because it's a straight line. So a straight line, we've got your y equals to x. Y equals to x. So your m is equals to 1. So it's like this angle here is 45 degrees. So when the positive gradient, we call it y equals to x, we say x plus c. But our c, you can see that our c, your y-intercept is 0 anyway. So it's actually y equals to x because c is 0. Similarly, in the negative gradient, you write it as a negative 1, so y equals to negative x plus c, but also c is your 0. So that's how easy it is to write the axis of symmetry for hyperbola where p and q are 0. In the following graphs of the hyperbola where p and q are not equal to 0, I'll also demonstrate how to choose your axis of symmetry, either negative or positive. Please share this video with others, and also like, comment, appreciate it, and subscribe if you haven't already. Thank you.